Hello and welcome into the examples video for lesson 13 for Precalculus 2. One thing I want to start by mentioning here, and I probably should have mentioned this in the content, but it's okay, we'll do it here, is what does a polar graph look like? And so you guys, I'm sure you all know, a rectangular coordinate system looks like this, right? It's basically a couple of number lines that intersect at 0, which is our origin. So depending on our values of x and y, we move left, right, up, or down. A polar graph, and we'll look actually at different types of figures that can be drawn in the next lesson. But as we're plotting these points, it's like, well, where am I plotting them? So now, instead of all the hash marks, what I have is a bunch of circles with distance radius 1, radius 2, radius 3, radius 4, etc., radius 5. My circles are getting worse, so I'll stop there. But that's what a polar coordinate system, what it looks like. It's a bunch of circles that keep getting bigger by units of 1. So the first set of examples that I want to do, and it is plotting all these different points. So plot the given points. First one we have is 4 negative pi over 2. So when we are plotting these points, we have to remember first a few things. First, theta first, move that direction. And then if r is greater than 0, move to theta, towards theta. And if r is less than 0, move opposite theta. So this is what we're going to be doing on every single one of these points that we're about to plot. So first of all, we're looking at theta. That's negative pi over 2. So that means what? We're moving clockwise, a distance of pi over 2, which puts me down here on the lower part of this axis. And then r is positive. So whatever direction theta is, I move the same distance, 1, 2, 3, 4 units out. So this here is my point 4, negative pi over 2. What if I have 1 and pi? So again, theta, it's positive, so I'm moving counterclockwise. And I have to move a distance of pi, which is what? Halfway around the circle. So over here on this axis, this is the direction my theta is pointing. And because r is positive, I move towards theta 1 unit, which would be right here. So if I had a bunch of circles, this would be the first circle, the first line, the first intersection of this circle with pi. So this is P1 in pi. And then lastly, if my point is negative 6, 4 pi over 3. So 4 pi over 3, that's positive, so I'm moving counterclockwise. And if I look at my unit circle, 4 pi over 3 is where? It's down here, down in quadrant 3. So this is my direction of theta, but I have to be careful now because my r is negative. And so because it's negative means I don't move this direction, but I have to move this opposite direction of theta. And then 6 units, 1, 2, 3, 4, 5, 6, puts me at this point out here, 6 units away from the origin, but in the direction opposite of 4 pi over 3 because the r is negative. So that's how we plot points on a polar coordinate system. So I only did 3. Hopefully that's enough for you guys to kind of see how this works. Negative theta, negative r, positive r's and thetas. But it really comes down to these 3 things. First, make sure you move theta first. And then depending on r, either move towards theta or move opposite theta. All right, the next set of problems. So we're given some polar coordinates. We want to find the corresponding rectangular coordinates. So the first one, my point is square root of 3, negative 5 pi over 6. So here is my suggestion to you. When you are doing problems like this, either converting when you are converting from polar to rectangular or rectangular to polar, plot this point so that you know which quadrant are you in. So that when you get a final answer, does it make sense that you're in the correct quadrant? So if I was to plot this point, negative 5 pi over 6, so I'm moving clockwise, takes me to here. And then square root of 3 means I'm out a distance here of square root of 3, meaning I'm in quadrant 3. So in quadrant 3, my x value and my y value are both negative. So when I'm done with this problem, I better end up with a negative answer for my coordinates. Now, we use those different equations that I gave you. So first, to figure out the x value, that's r times cosine of theta. Well, my r is square root of 3. Cosine of theta, so this is cosine of negative 5 pi over 6. And so negative cosine of negative 5 pi over 6 is negative root 3 over 2. So this is negative root 3 over 1 times negative root 3 over 2. So positive times negative is negative. Square root of 3 times square root of 3 is 3 all over 2. So this is my x value. And y we do similar except that it's sine. So it's r sine of theta. So my r is still root 3. And then sine of negative 5 pi over 6 is negative 1/2. So if I multiply these out, this is negative square root of 3 over 2. So in terms of an x, y coordinate point, this is negative 3/2, negative root 3 over 2, which is a point in quadrant 3. So I can be pretty sure that if I did my numbers correctly, that's the correct answer. And then second, I have the point 4, 2 pi over 3. So again, let's just draw a quick plot. 2 pi over 3 is up here in quadrant 2. R is positive, so I'm coming out here 4 units. So this guy is in quadrant 2, which means my x should be negative and my y should be positive. So let's check it out. X is r cosine of theta. So it's 4 times cosine of 2 pi over 3. Cosine of 2 pi over 3 is negative 1/2. So 4 times negative half is negative 2. And y is r sine of theta. So 4 times sine of 2 pi over 3. So 4 times positive root 3 over 2. The 4 cancels with the 2 and gives me 2, which gives me 2 root 3. So this point would be -2, +2 root 3, which is in quadrant 2. So again, I can feel pretty good that this is probably the correct answer. Well, let's go the other way. So given rectangular coordinates, find the polar equivalent. So convert to polar. And I want r to be greater than 0. And theta is between 0 and 2 pi. So I don't want an answer like 141 pi over 3. That's not going to cut it. So we want a value of theta that's between 0 and 2 pi. We want an r that is positive. So the first one, I have -3, 3. Same thing. Let's plot this, -3, 3. So that's up here in quadrant 2. So my values at the end better put me in quadrant 2. So first, r squared is x squared plus y squared. So r squared is -3 squared plus +3 squared. So r squared is 9 plus 9, which is 18. So take the square root, and that's why we say we want a positive r. Square root of 18, which if we simplify it, that's like 9 times 2. So 3 root 2 would be our value for r. And then to figure out theta, so tangent of theta is y over x, 3 over -3, which is -1. And again, in quadrant 2, where is tangent equal to -1? That's when theta is 3 pi over 4. So therefore, -3, 3 is a polar coordinate, would be written as 3 root 2 with my theta 3 pi over 4. What if I have 5 root 3 and -5? So again, let's just draw a rough sketch. X is positive, Y is negative. So I'm down here in quadrant 4. So when I'm trying to figure out my value for theta, I want a theta that's in quadrant 4. So now go ahead and do the work. R squared is x squared, 5 root 3 squared, plus y squared, -5 squared. So r squared, 25 times 3 is 75, plus -5 squared is 25, which is 100. So therefore, r is square root of 100, which of course is 10. So for this one, we just do 5 squared, that's 25. Square root of 3 squared is 3, so 25 times 3 is 75. That's how I got that. And tangent of theta is y, -5 over x, 5 over root 3. The 5's cancel out. So I get -1 over root 3, which if we rationalize it is -root 3 over 3. So that's what? That's one of my pi over 6 values for tangent. Where in quadrant 4 do I have a pi over 6? That's when theta is 11 pi over 6. So therefore, this polar point, I'm sorry, this rectangular point is x is equal, no, what am I doing here? Yeah, we're converting to polar. So my r is 10, sorry about that. My theta is 11 pi over 6. Tricked myself for a second. So that's converting from a polar point to a rectangular, rectangular to polar. Then the last thing we're going to look at is converting polar and rectangular equations. Now, one thing I'll sort of put here as a note, when we're doing polar equations, we try to write it as r equals something. So whatever the other portion is with our thetas and trig functions or whatever, usually we write it as r equals something. And that'll be important in the next lesson when we do polar graphing. So the first one is 3x equals 3y. So this is a rectangular equation. It has x's and y's. I want to get rid of that and have only r's and or thetas. So the first thing I can do is what? Divide both sides by 3. So I get x is equal to y. Now, use the equations we have. X is really what? R cosine of theta. And y is r sine of theta. So now do what? Well, now divide both sides by r. So I get cosine of theta is equal to sine of theta. So let's move everything over. So divide both sides by cosine of theta. So this becomes what? 1 is equal to sine over cosine. Well, what is sine over cosine? That's tangent. And so what I need to know here then is what value of theta is tangent equal to 1? And that's what? When theta is equal to pi over 4. So if I drew this on a polar graph, it's going to give me what? This line here, this 45-degree line. Well, this should generate the same picture as what I started with originally, which was what? 3x equals 3y. If I cancel the 3's, I get y equals x, and y equals x is what? It's the 45-degree line that goes through the origin. So here I know that, okay, I've done this correctly because I get the same picture whether I'm doing a rectangular equation, what I started with, or a polar equation, what I end up with. Now, I don't want to have an r here because it's the entire line, so all values of r count in this case, but that's why we have only a theta. Second one, how about if I have x squared plus y squared is equal to 3y? All right, well, first of all, x squared plus y squared is what? That is equal to r squared. And then y is equal to what? R, excuse me, r sine of theta. So I can do what? I can divide both sides by r. So one of these cancels with this r, gives me r equals. This r cancels with that, so just 3 sine of theta. So now I went from this rectangular equation, which would be a circle if you plotted the points for that one and put it in standard form, you're going to get a circle, which r 3 sine of theta is also a circle, as we'll see in next lesson. And then lastly, and this is all we're doing, it's just a game of trying to make these substitutions. So I have r equals 3. So if I drew that, 1, 2, 3, 1, 2, 3, 1, 2, 3. If I kept going 3 units out, I'm going to get what? I'm going to get a circle with the radius of 3. That's what this is saying, right? Radius is 3. So I have a circle with radius 3. So I need to get a rectangular equation that says the same thing. Well, what can I do here? I know I have r cosines of theta. That's not going to help me. R sine of theta is not going to help me. I have r squared is x squared plus y squared, but I don't have an r squared. But can I get an x squared? Yes, I can. How? Square both sides. So I get r squared is equal to 9. And now r squared is what? That's x squared plus y squared. So I get x squared plus y squared is 9. And if you think back to Math 126, when we were doing circles, this is what? It's a circle centered at the origin with the radius is the square root of this guy. Square root of 9 is 3. So it is a circle with radius 3, the same picture, no matter which way we went with the equation. So that's it. That's the examples for our polar coordinates and our conversions, polar to rectangular, rectangular to polar. So come on back and we will look at some polar graphs.